So what does number 15 say? It was log. Okay, log base 36 of fifth root of 6, right?
Yeah.
Okay. So so there are a couple of ways to do this. One is, so here this is log 6 of 6 to the power of 1/5, right? Yeah. And now, what is 36? You can rewrite the 36. So you can basically rewrite that as 6 squared, right? Yeah. So, and then here you have 6 to the power of 1/5. So, what should be the exponent of this? So you get 6 to the power of 1/5. So if you have 6 squared, what should you raise it to so that you get 6 to the power of 1/5? 1/10, right? So 6 squared to the power of 1/10 will be 6 to the power of 1/5. That's one way to do it. So it's 110, right? Since you're looking for the exponent. Another way to do it is this. You have log 36, 6 to the 1/5. Another way you can do it is you can rewrite this 6. So log 36, what's the 6? It's 36 to the 1/2, right? So kind of like make it the same as this, right? 36 is 6 is 36 to the power of 1/2, right? Root 36. So 6 is that to the power of 1/5. And again, that'll multiply to 1/10, that exponent. Okay? All right. And that will like make more sense after we do this lesson as well, I think. Okay? All right. So take a look at what we have here. We're going to talk about properties of logarithms. And the way in which we're going to talk about them is this. Okay. So suppose I were to ask you, what is log base 2 of, 32, right? So that's the exponent of 2 that would give you a 32, and that's a what? 5, right? That's a 5. Now, suppose I took the 32 and I split it up into 2 of its factors. So suppose I took the 32 and I split it up into 4 and 8. Okay? Now, what's the exponent of 2 that would give you a 4? 2. What's the exponent of 2 that would give you an 8? 3. What would you do to those exponents to get the original 5? Add them, right? Right? And so that's where this property that you've probably seen in Algebra 2 comes from. That if you have log of AB, it's log of A plus log of B. Why? Because log is the exponent. What is the exponent that gives you a 32? Well, if you take them in parts, it's the exponent that gives you a 4 plus the exponent that gives you an 8. Right? Does that sort of make sense? That's where the property comes from. Most of the time when we use the property, we don't think about it. But I like for, the students in Pracalc Honors to know where these things come from. Like they don't just fall out of the sky, right? Like there is something behind them. So similarly, if you have a division, right? Log b of x over y, now you subtract the exponents, right? So it's log x minus log y. And then if you have log base b x to the exponent, that exponent will come down and become a power, a coefficient. Okay? So let's use those properties in these. Okay. So suppose I have log base 2 of 32. Log base 2 of root 32. I write the 32 as 32 to the 1/2, right? That's root 32. Now what happens? The half that was an exponent will come down, So we get half log base 2 of 32. So this is half of, what's this? The exponent of the 2 that gives us the 32? 5. So that's 5 over 2. Okay? Yes? Yay. Okay. Here we go. 3 log 7, 49 to the power of 1/6. Okay. The 1/6 is going to come down. And then we have log base 7 of 49. So that's 1/2. And what's this logarithm? 2. That will give us a 1. And look at that. Who would have thought that that would just reduce to a 1, right? But look at that. That's logarithms for you. Okay? All right? Okay. So next, this 4 here is an exponent. It'll become a coefficient. The 2 will become a coefficient. So I have 4 times 3 ln of e minus 2 times 2 ln of e. That's 12. What's ln of e? Right? It's 1, right? Because it's 1. Remember what ln of e was? There is a base of e here. So what should be the exponent? So you get e back. It's 1. So that's 1. And that's 1 as well. So we get 12 minus 4, 8. Okay? How is that looking? All right. So, okay. So let's move on. And we want to expand this stuff here. Okay. So to expand a logarithm, we're going to use this property. And we're going to say if you have log of x times y, it's going to be log of x plus log of I. So however many elements you have inside your log, that's how many logarithms we're going to end up with. So here I have 2 elements. That means I'm going to end up with 2 logarithms. So it's going to be ln of x squared plus ln of root e. But then this 2 comes down. Plus, this is ln of, this was e to the half, right? So the half comes down, and it'll be half ln of e, right? And half ln of e is just a half, so that will be 2 ln of x plus a half. Okay? Yep, okay. So here, I've got 1, 2, 3 elements in that one. So I'm going to end up with 3 logarithms. So I have log cube root of x. Now, the 36 is in the denominator, so I have to subtract it. Minus log base 6 of 36. Y to the 4 is also in the denominator, so it also gets subtracted. Okay, so now what we have here is log base 6 x to the 1/3 minus, what's this one? 2 minus 4 log base 6 of y. So finally, the 1/3 also will come down. Minus, it's convention to write the, everything with the variables first. So I'm just going to switch the order there. Minus 2. Okay? So this is meant as a review of Algebra 2. You may or may not remember it from Zoom last year. But, we're going to go through a little bit more. And then I'm going to do something that's actually not in the book, but we need for next year. Okay, so here. The 2x minus 3 on top is one, what do you call it? One term together, right? So it's ln of 2x minus 3 minus ln of 3 minus ln of that whole thing. Okay, but you know what? I'm just going to switch it to exponent form from the beginning. 1/4, sorry. Okay. And so now the 1/4 will go down. Minus ln of 3 minus 1/4 ln of, so here we have ln of xyz, but you still have to expand that as well. So it will be ln of x plus ln of y plus ln of z. Okay? All right. Questions?
Wait, that's the final answer?
Yep, that's the final answer.
Oh, okay.
I'm fine with you distributing the 1/4 or not. It's the same. Okay, so next we're going to condense. Here we were expanding, and then we're going to condense. And to condense, it's literally like, you know, rewinding. So like you're undoing everything. So you see how, like, you know, everything, you know, all the exponents came down and became coefficients. So first, now all of those are going to become exponents again, and then we're just going to condense. It's literally like playing a video backwards. Okay, so the first thing, all of these coefficients become exponents. Okay, so I get log base 4x to the half minus log base 4 x minus 2 cubed. Okay, now condensing means you end up with one logarithm. So log base 4 x to the half, and since it's being subtracted, I divide by x minus 2 cubed. Okay. All right, so what about the next one? Yeah. Oh, that's up to you. Yeah, so, or you could say root x over this. That's up to you. Negative exponents are never okay, but root versus fractional exponents are like preference. Okay, so what about the next one? Go ahead and work it out. So what do we think? Yes and no. Sometimes people could do it in 1, and then sometimes people can do it in 2. So what do you guys think? ln of x plus 1 to the 5th times x to the 6th, like this. Okay? So, all right? Okay. All right. What we're going to do next is not in your book. However, it's like factoring and things that are more algebra-ish based. But I've noticed over the past like decade or whatever, I don't know how it happened, but like this stuff just sort of like disappeared from math books. But then students in calculus, and especially AP calculus, like you really need to know how to do this. But then we get to that point, and and we're like, wait, we never really practiced with this before. So it's been a couple years now where I've been adding it into since this is the exponential chapter, I've been adding it here. And then that's why you have a worksheet for homework for this, because I made the problems. One thing I did, well, we'll get to that later. But here, okay, so we're going to talk about factoring, right? And to do that, let's remind ourselves how we used to factor, like when we first started to factor, right? So suppose I have something like this. I don't know, 12a to the 4 plus 14a cubed, right? how would you factor? What would you factor out of this?
2a to the third.
2a to the third. Okay? So, how do you know to factor out a to the third and not anything else? That's the smallest valued exponent, right? And so, whoa, what do we get when you factor here? Plus 7, right? Okay, you do that like instinctively. But what does your brain do in the background for you to get that?
Divide.
You divide, right? You divide by 2a cubed. You divide by 2a cubed. That's how you do that. And if we like think about it further, when you do divide, what do you do with these exponents? You subtract them, right? That's how you get what you get, right? Okay, so let's do that here. What can we factor out from here? You have a -2 and a -x. I can factor out a -2 and a -6. I can factor out a -2. And also e to the x squared, right? So I factor out e to the x squared as well. So I factor out -2 e to the x squared, -2 e to the x squared. So from the first term, I have x left over plus 3, right? And that's that. That's the factored form. Okay? All right. So here, we're going to assume x is positive, right, for the next one. So we can factor out between the x's, we can factor out an x. Here I have e to the -4x, e to the -x. So if x was a positive number, which of those would be the smaller, the -4x or the -x? The -4x, right? So I'm going to factor out the -4x. Okay? So assume x is greater than 0. Okay? So when I divide by x e to the -4x, okay, what do I get? I get 5x, and then the e's go away, minus 2. The x's go away, and what do I have here? I have e to the, I'm going to subtract these exponents, right? -x minus -4x. Okay? So that will be x e to the -4x times 5x minus 2e to the 3x. Yeah.
Aren't you already distributing? So why?
Say that again? Here?
Yeah, like you're already distributing each, so why do you put it back in -2?
So I'm not distributing, I'm factoring it out, right? It's like here when we were factoring out an a cubed, right? It's like dividing each term by a cubed. So here you get 6, a to the 4 divided by a cubed is a, right? So we're dividing each time. Here, because you're dividing by identical things, they go away and you get a 1. Here, e to the -x divided by this, you have to subtract the exponents. Okay? And since we assumed that x is positive, we don't want to leave any negative exponents anywhere. So I'm going to move the e to the -4x to the denominator, which means I'm going to rewrite that as x over e to the 4x times 5x minus 2e to the 3x. Okay, Mayan, question?
Yeah. Why did you
Okay, so if you compare this with yours, I changed it a little bit. So go ahead. I think the exponents are different in a few places, right? So go ahead and add in these new exponents on your paper as well. So here, let's also make this an e to the x, so we have an easier time factoring. Okay? All right. So this is like straight out of one of the AP calculus problems that we solve. And so this is like, like if the problem takes, let's say like this long to solve, this will be like, like one step here, right? But it's supposed to be something that you could like quickly go past, but then if you haven't done it before, then like that's where students usually struggle, when it should be the calculus that you're struggling with. You know what I mean? So, okay. So let's see. The coefficients are 7, 2, and 1, so nothing to factor out there. Then I have this x plus 1 term. Look at the exponents of the x plus 1 term. I have a negative half, negative 3 over 2, and a 1. So of those, which one am I going to factor out? X plus 1 to the power of, which one is the lower numbered exponent? Negative half, negative 3 over 2, or 1? Negative 3 over 2, yeah? So I'm going to factor out x plus 1 to the power of negative 3 over 2. Now what about the e's? I have e to the x minus 2, e to the x, e to the x. So which one's smaller? X minus 2. So that's what I'm going to factor out. So again, that just means dividing by this term. Okay? I'm going to divide each of these by that. Negative 3 over 2, e to the x minus 2. You don't have to write it every single time. I like to in the beginning, just so we all see what it is that we're doing. Okay? So it's less abstract. Okay. So I have a 7 here. Okay. So look at the x plus 1. If you're dividing, we always subtract exponents. So here it's going to be negative a half minus 3 over 2. And then I have e to the x minus 2 over e to the x minus 2 will be a what? 1. Okay. Plus 2. Okay. The x plus 1s will go away because they have the same exponent, right? They're identical. And then I have e to the power of x minus 2 plus the x plus 1s will go away, and I have e to the power of x minus 2.
Would that be dividing by x plus 1 to the power of negative 3 over 2?
Oh, yes, it was. I'm so sorry. Yes, so that doesn't go away. I'm sorry. Thank you. So let's see. Okay, so we do have an extra term there. So we have x plus 1 minus, right? Never work in pen. Never work in pen.
I love having my notes in pen.
Don't do math in pen. That's always, right? That's like the one lesson. Okay. So e to the x minus 2. Okay. All right. Whew. Okay, so let's see. So here, I have x plus 1, e to the negative 3 over 2, e to the x minus 2. All right, so then I have 7, x plus 1 to the power of what? 1 plus 2. So look at what happens when you distribute that negative. You have e to the power of just 2. Yes? Plus x plus 1 to the power of how much? 5 over 2. E to the power of 2. You're pretty much done. Now you just have to scan and make sure you don't have any negative exponents, which here we do. So that term only has to move to the denominator. So that's going to be, let me see if I can fit that here. So it's going to be, I don't think I can fit it there. So it's going to be that whole thing divided by x plus 1 to the 3 over 2. All right? I'm actually, Scotty, you're going to hate me. So all of that, we're going to move it to the bottom. Okay? All right. How does that look? It's like factoring. It's like intense factoring. It's like, yeah, it's like factor, yeah, like extreme, right? It's like one of those extreme games, but with factoring.
Yeah.
Right?
Definitely
It should be like an Olympic sport, right? It's like part of like a pentathlon or something, right? Like you run, you swim, you bike, you do some of these factoring problems.
Yeah.
Yeah.
But they're not allowed to have negative exponents. X must be out there.
Right, but see, that depends on the x,
Okay.
so we don't know.
Okay.
That's why that's okay. But this, like, if it's explicitly negative 3 over 2, then, yeah. Okay, so let's move on to the next one. All right, so here, we're going to factor out a what? A 3, an x, and an e to the negative 1/2. So, what we get here is we're going to divide by 3x e to the negative 1/2. So when you divide this by that, it all goes away, so you have a 1 plus 3 e to the 1/2 minus negative 1/2. Okay, so here, okay, we do have a negative exponent in the initial e, so I'm going to make a fraction, thinking ahead. The first term, the 3x will be up here, but e to the 1/2 will be down here. And then in the parentheses, I have 1 plus 3 e to the 1. Okay? And whether you do e to the 1/2 or root e, it's the same. Over root e. Okay? So I would like for you to know that those two in the end are identical. Any of the two will be acceptable on my test or quiz. But like thinking ahead, right, like next year, if you were to take like a multiple choice test or whatever, you don't know which version will be given to you as one of the choices, so you should know that they're the same. Yeah.
So if you subtract. Oh wait, never mind.
It's kind of counterintuitive, right? Because those negative exponents and you're subtracting and then they're adding and they're, right? You're subtracting, but numbers are getting bigger. It's, yeah, write them down so you don't get confused. Okay, so let's take a look at this one. What are we going to factor out? Yep. And that's what we're dividing by. Okay, so first I have 4 minus x squared, 1/2 minus minus 1/2, minus x squared, and that just goes away. Okay, so this has a negative exponent. It's going to move to the denominator. So let's see what we've got left. We have here 4 minus x squared to the power of 1 minus x squared over 4 minus x squared to the 1/2. And then you simplify this, so it's 4 minus x squared minus x squared. Jake, question?
Yeah, I'm a little confused because if you're dividing by 4 minus x squared to the negative 1/2, wouldn't the first term just be like 1 to 1?
Here.
Yeah, wouldn't that be 1? No, just because you have 4 minus x squared divided by 4 minus x squared.
But this is a 1/2 and this is a negative 1/2. Like the exponent here is a 1/2 and this is a negative 1/2. So you add, you subtract the exponent, so it'll be 1/2 minus negative 1/2. 1/2 minus negative 1/2. But the second time, yes, it'll go away. So here, this will give you 4 minus 2x squared, right? Over this. I'll write it both ways so you can see. Okay? All right. Next one. Okay, next one, we're going to factor out 2x plus 3 to the negative 1/3. Okay, so we get 2x plus 3, 1/3 minus negative a third. Yeah.
We can do that, like, for the first term, when it's, like, the exact same as when you're saying, yeah, you can just write, like,
Oh, wait a minute. That is the same. Sorry. I'm sorry. That one was the same. So that will be 1 minus 2x plus 3, 1/3 minus negative a third. So this first one has a negative exponent, so it's going to move down. 2x plus 3 to the third. And then here I have 1 minus 2x plus 3. Be careful for this one because it doesn't become a 1. It'll just become 2/3. Okay? I moved this one down. Yes. And so if you wanted to write everything, so that's good enough, but if you also wanted to put everything in root form, it will also look like this. 1 minus cube root 2x plus 3 squared all over cube root 2x plus 3. Okay? And I know it doesn't look like what you're used to them looking like, you know, like it doesn't look like pretty, but hey, it is what it is, right? Life's complicated. Okay? Any questions? Okay. So, now, since we're, you know, doing all sorts of like Twilight Zone-y stuff today, why not do one more? Okay? All right. So, if you had, let's say, a to the x times a to the 2, how would you simplify that? Is it 2x? X plus 2, right? A to the x plus 2, right? Now, if you were given this, and you were asked to go this way and sort of decompose it, would you be able to? You've never been asked to, but if you were asked to, you would be able to, yeah? That's what we're going to do right now. So here, I have e to the x plus 4. I'm going to rewrite them as a product of two powers, e to the x times e to the 4. That's it. Okay? Again, why are we doing this? Because, you know, you need it next year, and you know, I want you to have seen it now. So what about here? E to the negative cosine x times e to the ln of 4. But how else does that simplify? It's just 4, so that's just 4 times e to the negative cosine x. Okay? Now, e to the kt plus c. Okay, this is like a famous thing, right? E to the kt plus c. It's a famous thing. You'll see it next year. You see less and less numbers the further up you go. Okay? Yeah. But do you miss them though? Because let's think back to like 6th grade, right? And what did you do in 6th grade? You did like, you know, you did this.
Yeah, that was annoying, honestly.
How much do you miss that?
Not that.
Right?
At least you could like wrap your brain around that.
The higher up in that go, the less numbers, and it becomes less math.
It's like English math, yeah. Okay. So, same thing here. It's going to look like e to the kt times e to the c. Yes? And that's all we're going to do right now. But just to show you why, okay, just look at this term, e to the kt. Have you seen that before?
In like the formula for...
And like that formula, right? So, yeah. So look. So this is good enough for this, right? But e is a constant, right? C is a constant. So e to the c is what kind of number?
Like a real number.
It's also a constant though, right? Like like if c was 5, e to the 5 is still some number, right? So instead of e to the c, can I just write that as like some constant? Give me a symbol to represent a constant. Like a letter, any letter. F, alpha, A, omega, right? So let's call it like A. Oh, how about, not Omicron. How about, since that's just a constant, let's call it y naught. That's a constant. Why not? Just call it y naught, right? What is that? If you rearrange it, what does that look like? Y naught e to the kt. Well, what's that? That's literally the formula from yesterday or 2 days ago. Y equals y naught e to the k. Oh my God, that's where it comes from. That's where it comes from. So in calculus, we actually do the derivation. In calculus, we do the derivation, and then we get to a point where we get e to the kt plus c. Then you have to do this step, decompose it into e to the kt, e to the c. Then you say to yourself, well, e to the c is just a constant. Let me just call it y naught. And you get that formula. So that's where that formula comes from. In fact, that's what I'm going to teach Monday to F period in AP Calc. So like that's literally, like it's so real. It's so real. Like 365 days from now, you will be learning that same thing, right? Like it's so real. Yeah. So, okay, so that's section 3.